we're back with part 2. Again, I know my videos are not the greatest. My computer webcam is kind of old and sad and not the most awesome thing, but I appreciate you guys putting up with this and trying to get through all of it. I'm hopeful that this one's only going to be 3 parts like the evolution one, and if you can get through kind of this boring stuff of me lecturing and teaching and doing some worksheets, next week will be more fun because we'll do some review. And I've got a Nearpod of those review games you like the little climb one where you get to pick your avatar and some of the matchy stuff within it. I've got the vocabulary stuff I'm trying to set up for you guys, and if you want me to, I can try and do some quizzes videos, or not quizzes videos, but some quizzes games, if you guys would be interested in that, to try to break this up and make it not so much I excel in YouTube videos. Great. So, bear with me, we're doing our best. We'll see what ideas Mr. Matlock comes up with when we meet on Thursday, and we'll try and make next week more interesting and fun for you guys. So let's pick back up where we left off yesterday, and that's going to be with reducing biodiversity. So obviously there's going to be several things that reduces biodiversity. Number 1 was going to be habitat loss. 2, we talked about invasive species, and now we're going to talk about pollution, which again can kind of go hand in hand with habitat loss a little bit. So we've got not just polluting the ground with garbage, trash, that kind of stuff. There's also air pollution and water pollution as well. With air pollution, that's going to be from cities and plants. Remember in the last chapter we talked about in Britain, the pollution being super bad to the point that the white birch trees turned black and the peppered moth populations fluctuated because of that. Well, that same type of air pollution can create what's known as smog. In a really rural area like where we live in, you're not going to really experience or see that. Smog is different than fog. Smog is literally like, I guess, kind of a dirty cloud of pollutants, chemicals in the air that's just not supposed to be there, that settles over typically really, really large cities. That's why a lot of people in big cities in China, you see, will wear the facial mask just in day-to-day life, not because of COVID-19 now, but even before that, it was a normal thing because we would get pollen readings, and they would be told how bad their air quality was that day. So certain big cities like that will have issues. Sometimes you can see smog over cities like New York and Detroit, but we've got pretty strict EPA, which is Environmental Protection Agency, guidelines to try to regulate that and keep that down. Water pollution. This again goes more in depth than just throwing garbage and trash and littering. This can be from things like pesticides. Now we're seeing a huge increase in microplastics. If you've ever had any of those hand scrubby things where it had those little tiny plasticky beads and stuff, if I'm not mistaken, I believe under President Obama, he ended up cutting those out completely because we're starting to see a buildup of what we call microplastics in our water. And these microplastics are, again, plastic, but they're small enough, they're getting inside of the organisms. They're small enough to pass through fish gills, and when they take in water and it getting trapped in their stomach because it's not natural, it doesn't break down very easy, and it's staying within their bodies, causing kind of toxicities with them. The pesticides I'll save for another slide because when we talk about atrazine frogs, you'll see some of the insanely huge impacts they can have. So let's look at a few pictures on these. So we've got acid rain, which is another way that air pollution can be represented. This again is going to happen in areas not like here. So let me scoot my picture over so you can see these a little bit better. Acid rain is not going to be as horrifying and sketchy as it sounds. It's not where it's going to rain and the flesh melts off your bones or anything like that. It's just going to lower the pH. And if you look at the pine tree in the upper left hand corner, you're going to see the discoloration. trees and plants have really soft and delicate tissues too, and unlike us, when acid rain or bad weather happens, they can't just run away inside. They're stuck out there dealing with it, and so it can damage their tissues. And you can see the big difference between the healthy limb and the almost bleached limb. To show you that acid rain is no joke, though, even though, again, it's not like going to cause like horrible burns and tissue damage if you get rained on by acid rain. It will probably be uncomfortable and you'll want to rinse that off. But the statue in the upper right-hand corner, that's the same statue. Those are before and after pictures of being repeatedly exposed to acid rain and it basically eroding and smoothing that statue. And down below, you can see smog settling over these larger cities. So again, it looks similar to fog, but this again is like a dirty fog full of chemicals and pollutants and stuff that you don't really want to breathe in and take in. Cars and exhaust are another thing that plays into this as well, but not the greatest of stuff. So this is going to be examples of air pollution. Now let's look at some examples of water pollution. These are frogs that have been exposed to a pesticide called atrazine. Now, a little background on what atrazine is. Atrazine is a pesticide that is illegal to use in many countries. I think actually all of Europe or the European Union has outlawed it and made it illegal to use the chemical atrazine as a pesticide. And if you forgot what a pesticide is, this is something we're going to put on crops to try to kill insects and pests from damaging the crops. So, even though it is illegal in many places, to my knowledge, it's still legal here in the United States. Let that sink in for a moment. We're using it a lot. And I say a lot, I mean we're using millions of tons of this stuff. Yeah, all over our crops, all the time. Now, with water pollution, think way back to your water cycle. We're putting the atrazine on our crops. It's going to rain on the crops and cause it to run off into groundwater and streams and rivers and all that kind of stuff. And eventually, after that precipitation rinses it off, it's going to evaporate right back on up and then rain right back on down. Which, in theory, may sound cool. It's like you get a double dose of pesticide and you don't have to spend more money on it. No. Not even close. A lot of these pesticides don't break down very quickly. They're artificial or they're made of certain chemicals that they have some serious hardcore staying power, and that's not a good thing because amphibians are going to be a key creature in kind of telling you the health of your aquatic or semi-aquatic ecosystem. And this is because of their very, very delicate skin, because they need to live in moist environments. They are going to be very susceptible to absorbing things through their skin, like these pesticides of atrazine. Now, these frogs, they were all captured in nature. They've not been experimented on in the lab. Nobody's like cut their legs off or stitched other legs on or done like some type of crazy Frankenstein experiment to them. This happened in nature. And what's so terrible about it is, look at them. They're malformed. They're disfigured. They're not functioning and looking the way they're supposed to. So this is going to decrease that biodiversity. The other thing that's so terrible is atrazine does something that we refer to as chemically castrating them. So let me explain that a little bit. If you take a male frog and you expose it to low levels of atrazine, so I'm not saying it lives an entire bucket of it, you're like injecting it. You expose it to low levels of atrazine. Atrazine acts as an estrogen, And if you've forgotten what estrogen is, you've got two main hormones with males and females. Both males and females have testosterone and estrogen. Testosterone is the main male hormone. It's going to be higher in men than women. Estrogen's the main female hormone. It's going to be higher in women than men. Atrazine is going to act like a very, very strong estrogen. So, if you expose these male frogs to low levels of atrazine, eventually those male frogs are going to turn into females. As in, you could introduce one of these atrazine male frogs to another male frog, and that atrazine male frog can have its babies. So it literally chemically castrates them. This stuff is strong enough that when taken into their bodies, it kind of completely and totally rewires them. It turns their testes, things that make sperm, into ovaries and producing eggs. So, yeah. And we're using lots and lots and lots of this stuff. There's even been a book that was written called Silent Spring, and springtime, like where we're in now, since we've had some nice pretty weather and some rain, in certain places you can probably hear lots and lots of frogs chirping. Well, the term silent spring, when you don't hear the chirping and croaking, that tells you that your frog numbers are decreasing, which again is going to be an indicator of not a healthy ecosystem. So this has been an ongoing problem. But yeah, this is like totally a real thing, not fake news, nope, this has been going on for a while. I learned about this when I was like a junior in college. Sorry, my cats are going crazy. That was back in 2012. It's 8 years ago. So, something kind of cool if you want to research and look into it, but scary but true thing. So here's one that I personally find much more heartbreaking. Another thing on my bucket list besides the Galapagos Islands is go to the Great Barrier Reef in Australia and snorkel or scuba dive there. So here you've got some amazing, gorgeous pictures of coral reefs and each of the different colors and shapes of corals you're seeing. Coral is alive. It's like this massive super community of lots and lots of little organisms all huddled together. So not only is the coral itself alive, but it is home to hundreds of other species. Fish hide in them, anemones attached to them, starfish, crabs, I mean the list goes on, eels, octopi. So these coral reefs are huge in supporting the biodiversities of these reef systems. And I mean, they're just fantastic and gorgeous to look at. Now, because coral is living, that means it can be killed. So what plays into a part of this is actually going to be global warming, which we'll talk about probably in a few more slides. With global warming, because the temperature is increasing, each organism has its own like level and happy place of temperatures that it likes. So with the water becoming warmer and warmer, it moves out of that range where that coral is happy and healthy and functional. And it can cause what we refer to as reef bleaching. And coral takes a really, really long time to grow. So we're starting to see many more of these reefs be bleached. I think the next slide shows you what I'm talking about. So top left, top right, and bottom right, you can see the horrible white color and just kind of grayish look to these reefs. There's absolutely no life in the one with the scuba diver. You can see just a few fish. I mean, compare it to this. The beautiful colors and just all the thriving life that's in there to becoming this. So this is terrible. And the two on the right side should be most concerning. That's just going from February to April. So this is happening quickly. And it takes, again, a really, really long time for these corals to grow and to become healthy. Other top picture in the middle with the seahorse and the Q-tip. That was an image chosen by National Geographic as one of the most powerful images just a few years ago, because that's an itty bitty little tiny baby seahorse, and there's so much pollution and garbage and junk in the ocean that just doesn't belong there, that it's literally clinging to it like it's normal. That's another thing with these microplastics, is they also leach chemicals. To be very honest with you, any plastic is going to leach chemicals. It's not really a good idea to ever heat or keep something frozen in plastic, because it will leach chemicals as it's heated and cooled down. So leaving these plastics and garbage in water allows these chemicals to also leach out and hurt the ecosystem. And yes, in case you're wondering, a lot of those chemicals that are leached out of the plastic do also function as estrogens. So it's not a great idea. If you want to cook something or preserve something, glass or metal, two best bets. That's why those tumblers got really, really popular, or you see if something's plastic now, it'll advertise no BPAs, which is one of those harmful plastics. I don't think I have to really explain what's going on with the seals and turtle below. So if you've ever heard people talk about cutting the things that go around your Coke cans or Gatorade or Powerade bottles, this is exactly why. It's not a myth or a joke that animals get caught up and tangled in them. This turtle has literally had this plastic around it for so long, its shell has grown and formed around it. And for those of you that don't realize this, turtles can't just be pulled out of their shell. Their spine and their ribs are fused to the back of their shell. So that's actually its ribs that have been deformed, which also means its organs are not laying in their correct and proper places because of this plastic that could have been really easy avoidable by a few snips of scissors. The sea lions in the bottom left corner, that's fishing line. Now the one that's farther on the right that's a deep cut from fishing line, and unless a human's ever able to get a hold of it, there's a good chance it's probably not going to get that off of it, and that can't be comfortable. So we really do have to start watching what we're doing, considering we've only explored 5% of our oceans, so there's no telling what we're hurting long term and what this is going to do. Next slides are kind of hard to look at.